2016 functions question on the Leaving Cert higher level was a basketball shot. You're told that Sarah took a shot at her first throw at the basket. The ball left her hand at A and entered the basket at B using the coordinate plane, with A being minus 0.5, 2.565, and B being 4.5, 3.05. The equation of the path of the center of the ball is y is equal to 0.27 minus 0.274 x squared plus 1.193 x plus 3.23, where both x and f are measured in meters. Find the max height reached by the ball. So we know the max height for any function, the slope of the tangent at the max height is equal to 0, and differentiation gives us the slope of the tangent. So we're going to differentiate this function minus 0.274, so f prime x is going to be equal to 2 274s is 0.548, and that would just leave me with an x, reduce the power by 1, plus 1.193. That would have to be equal to 0. So x is going to be equal to 1.193 divided by 0.548, which is going to give me 2.17, 3 decimal places here, 3 decimals in the question, 2.177 meters. Now that's not obviously the height, that's here somewhere. The height is up here, so we need the y value too. So y is the original function f of x. Y is equal to minus 0.274 times 2.177 to be squared plus 1.193 by 2.177 plus 3.23. So this is just calculator use. Just type this into your calculator, and the y value looks like it's just over 4, comes out at 4.5, 3 decimals here, 29 meters. So we write that point down. We have the max height. We're actually asked for the max height, so this is the answer for max height, but the point is 2.177 and 4.529. Part 2, we're asked to find the acute angle to the horizontal at which the ball entered the basket. Again, when we were looking at the slope here, so again we know the tan is slope, so we're looking for the slope at this point. Here's the ball entering the basket. So my x value is, what do we get for x? Well, we have it actually b, it's x is 4.5, so we just need to put 4.5 into the differentiated function. So f prime 4.5 will give us the tan of the angle. Previously it was 0 minus 0.548 by 4.5 plus 1.193, and we type this into our calculator. We're going to get a value of minus 1.273. 273 would be equal to the tan of theta. So we want to find the angle, so the inverse tan of minus 1.273 will give me a value of 51, or it's asked here to the nearest degree, so 51.8 degrees gives me a minus 51.8, but we're looking for the acute angle, so 52 degrees. Part 3 of this question is being a long-winded question, but it's just actually a translation question. Sarah took a second throw and it followed the parabola, this one here, g of x, from the point C, which is 0, 2. And you're told that under the translation, this new g of x is equal to the translation that maps the point A to the point C. So we need to look at what happens between here and here. So let's just write A and C down. A is this one, minus 0.5, 2.565, minus 0.5, 5.625. That's A. C is 0, 2, we're told. So we're looking at what's happening between my x values and my y values. So between the x value, we're going from here to here. So it's mapping A to C, so it's going up 0.5 plus 0.5 for x. And my y value is going down. Is that the right value for A? No, it's 2.5. Let me just change this. 2.565. So between A, we're at 2.565, so it's going down 0.565. So that's the mapping. That's what's happening here with each point between each function. And we're asked to find the max height of this this parabola A. So what's happening between here and here? That's the max point of the first one, and underneath is the max point of the second one. So we have our max point here. So we just need to apply what's happening at the mapping to this max point, 2.177 and 4.529. So we're going to add 0.5 and we're going to take away 0.565. So typing this into our calculator, we're going to get 2.677, just adding 0.5. And we apply the other one, we are going to get 3.964. Let me just double check that. Part 4, you're asked to find the equation of g of x. So there's several different methods can be used here. If we write down the points that we have, now we have C. If we have 3 points on a parabola, we can find its equation just by subbing in. So C is 0, 2. We have the max point. Let's call it D. D is 2.677 and 3.964. And we had where it went into the basket. Where did it go into the basket? B, 4.5, 3.05. B is 4.5, 3.05. And we know that g of x, all parabolas, ax squared plus bx plus c. So obviously if there's a 0 for x, this is going to give us c quite quickly. So g of 0 is equal to 0 plus 0 plus c, and that will be equal to 2. So c is equal to 2. So if we sub 2.677 in, g of 2.677, that's going to be equal to 3.964. So we're going to get a by 2.677 squared plus b by 2.677. Let me just give myself a bit more room. And then c we've already worked out to be 2, and that's going to be equal to 3.964. So typing this into a calculator, we're going to get 7.166a plus 2.677b, and then if I bring the 3.9 across, I'm going to get minus 1.964 equals 0. So I just need a third equation now, so I can get my a and b. So let's use this one here. G of 4.5 is going to be equal to 3.05. So a by 4.5 squared plus 4.5 times b, and then plus 2 is equal to 3.05. 4.5 squared is 20.25 plus 4.5b minus 1.05 is equal to 0. Well, let me just rewrite the numbers on the right. I left out my a. 20.25a plus 4.5b equals 1.05. Because we know our simultaneous equations here, I should have done the same up here. So how am I going to get the same amount of a's or the same amount of b's? So I'll just bring this one down and multiply it by whatever the b value is down here. Let me use that one, 4.5. So 7.166 by 4.5 is going to give me 32.247. That's a, plus 2.677 12.0465. That's times B. And that will be equal to 1.964 by 4.5, which is 8.838. And then multiplying this one by this coordinate, or this coefficient, will give me the same amount of b's, and then we can cancel them off. So I'm going to multiply this one by minus 2.677. We get the following. And if we combine these two lines, my b's will cancel, and I'm left with these two values for A is equal to this. So A is equal to minus 0.274 on my calculator, 0.274. And if we sub that back in, we're going to get a value for B of 1.462. So my parabola becomes g of x is equal to minus 0.274 x squared plus 1.462x plus 2. Marking scheme has a 3 here. I rounded off too early in this question, but don't make that same mistake. Part B of this question is a heptathlon question. You're given the event, you're given the x, the formula, the A, B, and C, and you're just asked in part 1 to just use the formula above to find the amount of points scored. So this is just substitution for the 200 meters. Y is equal to A, which you're told A, B, and C, and you're filling in your x value. So Y is equal to A, 4.99087 times B, which is 42.5, minus the x variable, which is 23.8, to the power of C, which is 1.81. So let's just type that into your calculator. Comes out at 1,000 for the javelin. Y is equal to A, which is 15.9803, times what she threw, 58.2, minus B, which is 3.8, to the power of C, which is 1.04. And if you type that into your calculator, you're going to get 1020. So she has scored 20 points. Part 2 of this question, you're told that the world record in javelin would merit a score of 1295 points, and find this world record. So what's the formula for javelin? Y is equal to A times x minus B to the power C. And the variables we have are, we have Y is equal to 15.9803. And this is the real formula that they use to work out the world record in javelin. I think the answer is slightly off the real world record. And we have x minus 3.8 to the power of 1.04. So we're looking for x. So this is going to be a log question that you can see. So the points gained will be 1295. That equals 15.9803 by x minus 3.8 to the power of 1.04. So dividing 1295 by 15.9803, we get 81.0373. 81.0373 is equal to x minus 3.8 to the power of 1.04. Now, we normally, this doesn't come up a lot where we have a variable minus a variable in here. So if we just allow that to equal, let's say A, it might be easier to simplify it down. Then we can just say at the end A is equal to x minus 3.8. So we're going to get the log of both sides. So 1.04 by the log of A equals the log of 81.0373. So we divide the log of 81.0373 by 1.04. We get 1.83527. 1.83527. That's going to be equal to the log of A. Now what this means is there's a missing number in here. We don't have a base here, so when there's no base, it's a 10. So what we say is 10 to the power of 1.83527 is equal to A, and this works out to be A is 68.43. And if we add on, we need to A is equal to, what did we say, x minus 3.8. So x minus 3.8 is equal to 68.43. So we're going to have to add on that 3.8. So x is equal to 72.23. 72.23. But for all of you athletics buffs, you know that the women's world record is 72.28. And it's held by Barbara Spotakova. Last part of this question, another log question. So you're told the points for the 800 meter race are the same for the 200, but with different constants, or to calculate the formula, same formula used. We're told A is this guy, B is this guy, and we're asked to find C. And we're told that she ran it in 2 minutes, 1.84 seconds. So filling this information in, she got 1087. A is 0.11193. B is 254. And X is what she ran it in, which is 2 minutes. Well, that's 120 plus 1.84, so 121. And it's a minus 121.84 to the power C. So simplifying this down, 1087 divided by 0.11193 is equal to 132.16 to the power C. So the left hand side gives 9711.43, 9711.43. And we're going to get the log of both sides, so we're starting to write C by the log of 132.16 is equal to the log of the left. So I divide across by the log of 132.16, and that will give me C. So C is equal to 1.88 in this question. So quite a long functions question.